Hello everyone. In this video, we will discuss search and rotated sorted array question, which is present in ninth question of the arrays in the 75 LeetCode questions. So, okay, let's start diving deep into it. So yeah, I'll follow these 8 steps and let's start. Let me highlight this actually. All right. So let me highlight this, as I think this is the most important part of this, most important steps of this walkthrough. So yeah, so let's start by reading the question first. And then, oh God, what's happening with the pencil? All right, and then input and the output, and then test cases, then brute force and efficient. Okay. So let's say there is an, yeah, question says there is an integer num sorted in ascending order with distinct value. Okay, then things we know from here is it's a vector, it has distinct value. Vector or array, whatever you like to say. Prior to being passed to your function, nums is possibly rotated at any unknown pivot index. All right. Nums k plus 0 index 0, 1, 2, 3, 4. This is okay. Given the array after the possible rotation and array target, return the target of its nums, or -1 if it does not exist. You must write an algorithm in logarithmic n time. So I think this question is pretty easy if they ask us to solve in big O of n, because in that case what we can just do is iterate through this array and keep a minimum value and then just at the end return that minimum value. But because they want it in logarithmic n, so whenever these two things come, sorted plus logarithmic n, we should think about utilizing binary search algorithm. So yeah, binary search is basically divide the array half and move towards if this is the array, it divides half, then move towards where you might find the number, and then you further divide that half, move towards the where you find the number and stuff like that. So you can go online and read more about binary search. This is an enhanced version of binary search, so I'll discuss this. And yeah, so I think we got understood the question very clearly. The array is sorted. Array can be sorted at any position. So let's say if 1, 2, 3, 4, this is the array. The array can be also 1, 2, 3. This one array can be also 1, 2, 3, 4. Array can be also 2, 3, 4. Array can be rotated anytime, but if you see, it's it's like in sorted order, but reversed also. So okay, input. Let's do input. In this case, is our vector of int, and here we can say it will always size will always be greater than equals to 1. So null vector will never be passed. And then the value of nums are unique, which is these are unique values, which is good. Nums in ascending order array that is possibly rotated. Okay, target. Okay, sounds good. So yeah, input is this. Output of this question is we have to return an integer, and now integer can be anything from the array. Actually, let me think about it. Return the index of target. Yeah, okay. So either we return the index of the target, or we return -1 if we found nothing. So basically an int, nothing else. That's what we're returning. Now let's look into this question. And the way I'd like to, like brute force big of n, we already discussed. Just iterate through array and keep a min value, which will start with int max. And let's say when I equals to 0, min will become 1. I is equals to 1, min will stay 1. I is equals to 2, min will stay 1 because 3 is bigger than 1, then 1, then 1 because 4 is bigger than 1, 5 is bigger than 1. So in the end we return 1. Actually, hold on. This question asks about the number we want to find. So instead of returning the minimum, what I'm saying is big of n solution will be iterate through it, and at each iteration we'll check if the number exists. If the number exists, we are going to just return the index. If not, then we'll get out of the for loop and return -1. That's a big of n. Now big of, let's look at big of logarithmic n. So let's say in the question target comes out to be 1, and let's say nums can be 5 if let's say this is the 1 2 3 4 5. Now this can be of 5 possibilities: 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5, 1 2 3 4 5. Now this array can be only represented in 5 ways. Let's say an array which is sorted but can be rotated like this time. Now if you see, what binary search does is it divides the array in the half, so which we can start doing. And then if you see, every time you divide this array in the half, one half will be always sorted. So this is sorted, this is not sorted, this is also sorted. But yeah, what I'm trying to tell you is like one half is always sorted. But in this case, let me actually take another one. This is not sorted. Now let's say this is sorted, this is not sorted, this is sorted, this is not sorted, then again this is sorted, this is not sorted. So if you see, the only case where all entire array is sorted is when it is in the same, it's rotated by 0 index, like that means it's not rotated at all. In all the other cases, there's always be one of the array, one half will always be sorted. So if we can figure out which we divide, let's say in binary search we divide this array, and then if we can figure out which part of the array is sorted, that means that once we figure out which part is sorted, then we can say, all right, what, let's say let's pick this, actually let's pick this one, let's pick this one. Yeah, so binary search breaks these two array. Then first array will be 3 4 5, second let's say 5 1 2. Now in this both you can say this is sorted. Now in this array what we can say, we can always say that anything that coming in the middle is always gonna be greater than this one and always gonna be less than this one. So what we can say is like, from sorted array we can definitely guarantee that if the target that we are looking for doesn't lie in between the sorted array, that it's in the opposite direction. It's always guaranteed. But if it does, that means it lies here, because it is remember, the initial assumption is that this is always a sorted array. It's just like replaced. So the whatever half we find which is still sorted, we're going to check if the target exists between that one. If it does, then we move our next our pointer towards that one. If not, then we go to the opposite direction. So let me actually write the code for it. So left equals to 0. Let's say 2 pointer, which will be nums dot size -1. Now we'll take, yeah, target is already given, so let's say target equals to number, some random number. Now what we're going to do is we're going to do while L less than equals to R. This is like a typical binary search question, like while loop. Now every time what we're gonna do is, first we're gonna calculate a mid for that. So int mid is equals to left plus R minus L by 2. Once you calculate the mid, we can quickly check this big of, we can do quickly three big of one expression, which will be like if nums mid is equals to target, then return mid. We can also do if nums left is equals to target, then we return L. Same for the right part, nums R is equals to target, return R. Now if you see, we checked this, this, and this. The only thing to check is the if which side, if it doesn't, the minimum doesn't exist here. Sorry, if the target doesn't exist here, then we will just have to look which side, which we'll first say which side is sorted, and then we'll see if there exists or not. So what we can say is, let's say if nums of mid is greater than nums of L. That means, let's say 1, 2, 3, 4, 5. This is mid, this is L, this is R. If nums of mid is greater than nums of L, that means this is sorted. So what we're gonna do, check if target is greater than nums of mid and target is smaller than, nums of L and target is smaller than nums of mid. Once we figure out that this is a sorted array, what we'll see we are doing is, if target is bigger than this and target is smaller than this, then what we're going to do, we're going to move this right part to here. So right becomes mid minus 1. Else, if that's not the case, so basically what we concluded here in this loop is, if this is sorted and the target that we want doesn't exist here, that means it definitely exists there. So what we're going to do is say L is equals to mid plus 1. And else, now this is the tricky part. This is, if we are going to come here only when we are going to get that nums mid left part is not sorted. So that means that right part is sorted. So the only thing that we know until here is right half is sorted. Now we still have to figure out, let's say, let me take a good example. Let's say 1, 2, 3, 4, 5, 1, 2, 3. Yeah. Let me take 4, 5, 1, 2, 3. Mid is this. This is left. This is R. So we'll come here in this example. We'll come in this loop and say right part is sorted. Now, if we are looking for number 4, let's say number 5, then we can't just say, once we figure out right part is sorted, that all right, move the pointer this one. We have to still check if the target that we want still exists in that. So exact same code like this, which is target is greater than nums mid. Okay. Pencil stops working. Just a second. Just trying to connect my pencil here. All right. Yeah, if target is greater than nums mid and if target is less than nums R, that means right side is sorted plus target is lies between right side. We're gonna do L is equals to mid plus 1. Or else what we can do, what we decided here is right is sorted, but the number doesn't lie on the right in the sorted array, so we'll be like, all right, R is equals to mid minus 1. So now in this algorithm, yeah, either we return the number when we find it, or else this loop will just keep running, and at the end we're going to return minus 1. Yeah, so that's the code. Now if you think about it, we are always dividing big of n, and these are like big of 1 operations. Actually, let me change the color. This is big of 1, this is big of 1, this is big of 1, then again big of 1 operations. So these are all constant operations. The only is like this, n, so it becomes n by 2 in next, then it becomes n by 2 star 2, then n by 2 star 2 star. So basically every time we run, this loop gets decreased itself in half. So yeah, logarithmic n is the time complexity here. Now let me quickly run this code. So what we have to say is, let's say add and then right pointer is equals to nums dot size. We already see that in the input it's mentioned that the nums is always greater than 1, that it's never null, so we should be good there. And yeah, target is already given, so I'll just start the loop while L is less than equals to R. We're gonna check mid plus R minus L by 2. Once that is done, we're gonna check 3 quick conditions. If target return L. Now 2 more times. R return R. And if this is mid, return mid. Once this is done, now the real game begins of moving the pointers. So what I'm gonna do is, if nums L is smaller than nums mid, that means left half is sorted. Once we figure that out, what we're gonna do is, if target is greater than nums L and target is smaller than nums mid, that means left, this will say, all right, left is sorted, and then say target greater than nums L, less than nums mid, target also lies there. So we're gonna just say R is equals to mid minus 1. If this is not true, that means else L is equals to mid plus 1. Now this means this code will be executed then when right half is sorted. And what we're going to do here is, let me actually just copy this and say, if target is greater than nums mid and target is smaller than nums R, that means L is equals to mid. The number lies in the right half. So what do we say? Like, all right, we are here because right half is sorted, and say the target is greater than mid and smaller than R. That means target lies in that too. So we'll just do L is equals mid plus 1. Or else what we'll do is R equals to mid minus 1. And then in worst case scenario, if we don't find a number, we are just going to return minus 1, just like in question. Yeah, so let me go through that algorithm again. We start L from 0, R from the last index. We start this loop, we calculate mid at each point, L, R, mid, we check. And if we find, we return the index. If we don't, then we figure out which half does this exist. Then we say this, L is greater than, L is smaller than mid. That says, this tells us that left half is sorted. We go in, we say target is greater than nums L, target less than nums mid. This tells us if the target exists in the left half. If it does, then yeah, we want to iterate the left half and don't care about right half. If it doesn't, that means we want to care about right half and doesn't care about left half. So we move L. And we come here, because this is not true, that means nums of mid is smaller than nums of right. That means right half is sorted, then target is greater than nums mid, and target less than nums R, L mid for long. Yeah, that means right half is sorted and target lies between right half. Yeah, we want to move there now. If it doesn't, that means target lies on left half, so we'll do that. And yeah, repeat again for the same, and at the end we just return minus 1. So yeah, this looks good to me. Yeah, so yeah, looks good. Big of n time. For efficient solutions, we can always, let's see some efficient solution actually. Solutions, let's do C++ because that's what we're solving. So they're only checking for nums mid is equals to target return mid. Check if the left half is sorted. Yeah, they're doing the same thing. They're just not doing these two computations, because in their code they are making sure that the mid eventually goes to the minimum one, which makes sense too. And let's see. Yeah, this works. Actually, let's see if we can make our code work like this. If we do this and then we remove these, let's see what happens. All right, nums L. Let's see what went wrong. It should be that question go. Yeah, what they're doing is this. Nums L is that's an equals to nums mid. Let's run it again. All right, it succeeded. So yeah, if you remove those two variables, just make sure unequal conditions here so that we can say that on the edges it still exists. But yeah, looks good. And big of n and beats 100%. It looks like those additional two cases every time we're doing was taking high time. So adding that as equal sign saves some time. But yeah, thanks everyone. Let me know if you have any questions in the comment section. Thank you.